Today we are going to look at nets of 3D objects. We've looked at types of 3D objects and we have found volume with 3D objects, done word problems with 3D objects. Before we get to nets, let's do a quick review on prisms and pyramids. Prisms are 3D objects that have two parallel congruent bases and flat faces, like the triangular prism, the rectangular prism, the pentagonal prism, and the hexagonal prism. Pyramids, on the other hand, are 3D objects that have a base, like here's a rectangle, a hexagon, a heptagon, a decagon, but their sides are triangular faces and they meet at a point, and that point in math is called an apex, but you don't need to know that term yet. But they do come to a point. And if you hadn't thought about it, look at all these different kinds of pyramids. Here are triangular sides, here are triangular sides, here are triangular sides, and here are triangular sides. So if you're having trouble determining whether something is a prism or a pyramid, sides, the lateral around the side, are rectangles or whether they are triangles. So a net is a two-dimensional pattern of a three-dimensional object. The net lies flat, but it can be folded to create the 3D shape. Nets can be very useful for finding surface area, which is something that we are going to be working on in our next lesson. So the net lays flat. So we said that nets are a flat pattern for a 3D shape. So if we look at this shape, we've got a cube here. And we say flat. When we say a flat version, we don't mean this. This is not a net. So instead, a net is if you took a cube and you cut it and opened it up and you kept cutting it until you could lay it flat in one piece. That is a net. This net makes a rectangular prism. If we look at a net like this one, can anybody determine what this would be? Well, if we take this and we fold it, we get a triangular pyramid. Let's look at one more. If I take this shape, this is a triangular prism. And if we cut it so that we could fold it flat, it would look like this. Many times there's more than one possible net for an object. If we look at all of these different arrangements, many of them could make a cube, but some of them could not. Some of you have really good spatial intelligence, better than me. Those of you that are artists probably can tell right away which ones will make cubes. Can you see which ones might make a cube and which ones wouldn't? The orange colored nets can all be folded into a cube. The white nets cannot be folded into a cube. So even though this has 1, 2, 3, 4, 5, 6 squares, there's no way to fold it into a cube. Some of the sides would overlap. So all of these white ones are not possible. But look, here are 1, 2, 3, 4, 5 different ways that you could make a net for a cube. And there's more possibilities. That's just some of them. Let's take a look at a sample problem. Match the 3D figure to the right with its appropriate net below. Again, some of you can probably just see it. Others of you, like me, have to think about it a bit. So let's look at this shape. It's a triangular prism, and it's got 1, 2, this bottom would be 3, this end would be 4, and this end would be 5 faces. So if you're trying to figure out which net matches a shape, it's always a good idea to figure out how many faces the shape would have. And if we look at this, we've got the two ends are triangles. So we have two, it's tough to draw with this. triangles, and we have 3 rectangles. So if we take a look at these different options, this has 5 faces, but it's got 4 triangles and 1 rectangle. This has 3 rectangles and 2 triangles. That looks about right. This one has 2 triangles, but it's got 1, 2, 3, 4 rectangles, so it would have an extra rectangle. So that means that the right choice is B. There's another video from Khan Academy that will help you a little more with nets.